Okay, so what we have here is chapter 5. These are reactions at supports. Okay, so what's a support? This is a support right here at A, and this is a support here at C. As you can see, these are different types of support. There's this one, and then there's this one, right? They're different. So what does that mean? Here you gotta look, and you're gonna see that there's different types. The first type is roller, okay? So the roller, as you can see here, I drew it. You can move to the left, you can move to the right, and then you can rotate that lever. You can go up and down. In a pin, you can move, you cannot move left or right, and you cannot move up and down, but you can rotate. In a fixed lever, or a fixed support, sorry, you cannot do anything. You cannot move up and down, you cannot move left and right, and you cannot rotate. So, if you see a support, the first thing you have to ask yourself is, can it go up and down? No. Can it go left and right? Nope. And if it doesn't have if it cannot do something, that means that there's going to be a force applied. For example, here you can see this one cannot go up and down. The roller cannot go up and down. So there's going to be a reaction force at the Y. For the pin, it cannot go up and down, and it cannot go left or right, but it can rotate. So, since it can rotate, we're not going to have the rotation, we're going to have the Rx and Ry because it cannot do either. For here, you cannot do any of them. So there's going to be an Rx, there's going to be an Ry, and there's going to be a moment. A moment is when it can rotate, right? So since this particular one cannot rotate, there's going to be a moment, and that shows right there. Okay, so the motion, this is the motion that it can do. So the force is going to be in the y direction. Same here. You guys get the gist of it. Okay, so the first step of this problem uh, should be asking yourself, what kind of support systems do I have, right? So you can see this support system at the A is going to be a roller. And when we look at the roller, it can go left or right and it can rotate, but it cannot go up and down. So automatically, we know that there's a force going in the y direction. So we're going to call that AY. And for this one, this is the pinned support. And we already know that it cannot go left or right and it cannot go up and down, but it can rotate. So that means that there's going to be a force in the y direction, so it's going to be Cy, and there's going to be a force in the x direction. Now, you may ask yourself, how do I know what direction the force is going? You may not know at first, it might not be obvious, but whenever you find the equations that we're going to do in a little bit, and if the answer to Cx is negative, that means that the force is not going in the direction that you put it. It's going in the opposite direction. You'll see what I mean in a second. So the first step should be, labeling everything, obviously. So you label this, the V is 6 for me, 10, the A is 2.5, and I'm going to put the forces in black. The force here is at F1 is going to be 1.4, and the force at F2 is going to be 2. Okay? So now, the first thing we should do is know that Fy, let's do Fx first, Fx has to equal to 0, because this is all in equilibrium. It has to be in equilibrium. This whole chapter is about equilibrium, okay? Fy equals to 0, and the moment about a point, any point. That's a beautiful thing about it. You can pick any point to do the moment. Usually you have to pick the easiest point. For example, if you use point C, then you don't have to worry about any of these forces. So we're gonna say point C equals 0. So what should your next step be? The next step should be the following: taking every single force in the x, okay? because that's the what this means is addition or the sum of all the forces in the x. So the first force that's going in the x direction is going to be negative because it's going to the left, it's going that way. It's going to be negative 1.4 because that's the force times cosine of 30, okay, plus, or yeah, let's do plus first so you guys can see what I mean, plus cx um equals to 0. Okay, so if we do some simple algebra here, we can see that 1.4 times cosine of 30 equals 1.21. So we already know that cx is 1.2, so we're going to write it here 1.2, and the unit is kip. So that was easy. Now we're going to do the same thing for the fy. Okay, we are going to first see, we need the f1 is going to be negative 1.4 times sine of 30. Okay, that's for f1, plus cy plus ay equals 0. Now since there's two unknowns, that means that we need another equation. Okay, and the next equation is going to be the moment equation at point C. Since it's at point C, then we don't have to worry about any of these forces. We only have to worry about the F2, and we have to worry about the AY because it's what's going to make it rotate. Because none of these forces is going to make this system rotate, right? So to start with AY, so you do AY times the distance. Now, since the force is in the Y, the distance is going to be in the X. The B is 6 plus 10 is 16. Okay, and that is going to make it rotate clockwise, so it's going to be negative. And then the force in the 2, the moment is going to make it's going to be positive because it's going to make it rotate counterclockwise. So it's going to be F2, which is 2, times the distance from the X. I mean the distance in the X because the force is in the Y. Now, since this is 2.5 right here, you're going to subtract this 2.5 from 10, because it's right here. The force is going all the way up here, and it's giving you this. So it's going to be 10 minus 2.5, which is 7.5. Okay, minus 7.5 is going to equal to 0. Okay, so if you do algebra here, then we are going to come up with AY equals, it's going to be 2.75, 2 times 7.5, 15, so it's going to be 15 over 16, and it's going to be 0.94. Okay, so that's your AY. And lastly, we need to figure out what the CY is because it's the only value that we haven't solved for. Now, we bring this equation down, and we have 1.4, negative 1.4 times the sine of 30 plus CY plus AY, which we already know what it is 0.94 equals here I'm missing one. Sorry, here I'm missing minus 2 because of this force right here. Equals 0. Okay, yeah. And then 0.94 minus 2 equals 0. Perfect. So we're gonna do negative 1.4 times the sine of 30. It's gonna be negative 0.7 plus cy plus uh and we separate these and we send the cy, we leave it alone. If you do the algebra, you're gonna be left off with 0.94 minus 2, it's gonna be 1.76, which is 1.8. They're both gonna come out to negative, and you divide both sides by negative 1, so it's gonna be 1.8. Okay, so that's your cy. I hope you guys understood that problem. Um, yeah, thank you.